Okay. Hello and welcome, everybody. I hope that you are having a wonderful day so far. This is the grade 9 hour of freemathhelp.ca. So we are going to be covering grade 9 topics, and what we do every week is we teach a lesson. But if you have questions from your distance learning, you are more than welcome to leave them in the chat for us to answer for you. So I'm just going to do a quick sound check here, make sure that everything I'm saying is coming through to you guys, and then we'll get started right away. Okay? Alrighty, so we are back. I hope that you guys are having a wonderful day so far and that you're healthy and safe out there. What we're going to be learning today is actually polynomial expressions. This is a major part of math that is super important, and I know that a lot of people struggle with it. So as we get closer to the end of the semester, I thought it would be really good for us to go over these skills and just make sure that everyone's feeling comfortable with them. As always, if you have questions, you're more than welcome to leave them in the chat. That's what the chat is there for. So, without further ado, we're going to get started. All right. So, when we talk about adding and subtracting polynomial expressions, let me put my pen on here. So, when we talk about adding and subtracting polynomial expressions, there are a couple standard rules that are really important. And one thing that I want everyone to understand is that polynomial expressions act in a way, when we're adding and subtracting them, very much like integer expressions. So polynomial. Now what that means is that we have to be aware of what the changing signs are going to be. So when we talk about integers in general, it's very important that you guys have a good understanding of how integer expressions change. So before we start with polynomials, I would actually like us to do a quick refresher on how we add and subtract integers. Now, the first thing we want to do is try something like this. So let's say I have 4 plus negative 5. Okay, so this is my question here. It's 4 plus negative 5. What does it equal? And this is something that a lot of kids in grade 9 tend to struggle with, and I think it's because there's such a long time for most people between grade 8 math and grade 9 math, and it's not something that was very much a huge part of the grade 8 curriculum, so I actually think it should be a bigger part of the grade 8 curriculum. But anyways, so what I want you guys to understand first and foremost is that this, even though it looks like an addition, it's technically a multiplication right here. And just give me a second, guys. Sorry, guys, I had to sneeze. So what's really happening here is that this is the same thing as saying 4 plus 1 times negative 5. And now, knowing BEDMAS, we know that this here is a multiplication. So what are our multiplication rules with positive and negative? Well, we have a positive times a positive. So when we have positive times a positive, that stays positive. And the way I like to remember this is that when you have two positive people staying together, hanging out, they're going to keep being positive. They're not going to do anything different, right? Now, if you have a positive times a negative, it's like having one positive person hanging out with a really negative person. And what happens in that situation is that the negative person can bring the positive person down. And so the answer to this is going to be a negative number. And then my third analogy here is when you have a negative person hanging out with a negative person, so a negative times a negative. And when you get two negative people together, they start talking about their problems, they start complaining, and they really get it all off their chests, and it becomes positive. So a negative times a negative becomes a positive. So keeping these rules in mind, just gonna, wow, not two S's. My goodness. There we go. Keeping these rules in mind, as we practice our integers is very important, right? So if I have a positive and a negative here, this needs to become one term, okay? So what's going to happen? Positive 1 times negative 5 is negative 5. So 4 stays the same. These squish together. I call this the squish step. And this just becomes 4 minus 5. We're just going to put our equal signs in to do that properly. And then 4 minus 5 is negative 1. And if you're confused as to why it's negative 1, definitely just practice on your integer lines here. You know, we've got, if this is 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. So that's 0. And then put these numbers in. Not as much space, but that's okay. So say I started at 4, and I moved over 1, 2, 3, 4, 5, I'm going to land here at negative 1. Okay, everybody? And if anyone is confused by anything, you're more than welcome to leave a question in the chat. One thing that I really always make sure for our students in our math mastery program is that they are practicing integers to the max, because at the end of the day, so much of math comes down to understanding integers. And if you are confused by this, that's okay. It's fine to be confused. That's just part of learning. And ultimately, it'll help you become a better math student when you practice, even if you're confused, because we learn by doing. And that's something that not a lot of people get told when they're younger. We think that people are either good at math or bad at math, and that's just not true. Math is a practice. It's the same thing as becoming a good runner or becoming a good athlete. You have to practice all the time, or else you're going to get rusty. And that's what makes math hard, is that it's easy to forget because it's not something we do naturally every day. And so it's really important that we practice this as much as we can. Okay, so moving forward, when we talk about polynomial expressions, like I said, integers are very important. So I'm going to show you guys one more integer statement here. So if I have 7 minus negative 5, what we want to do here is, again, squish together this part of this equation. We need to get rid of this thing and make it into one piece. And as we know from over here, a negative times a negative is a positive. So that just squishes into one positive 5. Okay? And then the answer here is going to be 12. So that's my mini refresher on integers. If you haven't practiced integers in a long time, I highly recommend, downloading some worksheets. If you're in grade 9 and you're confused by everything that's been happening in your math class this year, I really, really recommend just practicing as much as you can. We have something called a math mastery program, the Elite Math Mastery Program, and if you did want to check that out, you're more than welcome to on our website, which you can see there at the bottom of the page, scholarlyelite.com. That program is built to help you create and really truly master these core fundamental math skills that you're going to use over and over again, and it has made a huge difference in many kids' lives. So I highly recommend, if anyone is really struggling, that you at least practice, and if you find that the practice is difficult, reach out and look at getting that extra support. Okay, so without further ado, let's talk a little bit about the distributive properties. So when a sum is multiplied by a number, each value in the sum is multiplied by the number separately. So that sounds really fancy, but I'm going to show you what I mean. So let's say I had 5 times 10x plus 5. What's really important to remember here is that we're going to use what I like to call our Saber-Tooth method, and I'll show you why. And I didn't make that up, actually. One of my students made that up. So we're going to multiply this number 5 into each part of this statement inside the brackets. So 5 times 10x is going to be 50x, because we're just multiplying the coefficient. And then 5 times 5 is 25. And that's our final answer for this question. Now, The reason that these get really complex is because you have to understand exponent laws. If you missed last week's exponent laws lesson, I highly recommend that after we do today's lesson, you go back and you watch the grade 9 class from last week. It's up on our YouTube channel. And in that class, I discuss a lot of the exponent laws and how to apply them in a more effective way. And we're probably going to do another exponent laws lesson down the line before the end of the school year, just because it is such an important lesson and it is such an important skill in math that is going to come up over and over again. Okay, guys, so let's go ahead and try another example. This time with a negative number being multiplied in. So let's say my question is given to me and it is like -3 times 4x plus 2. Now, because this number is negative, it's very important to remember our positive and negative multiplication rules. So let's ask ourselves a couple questions. When we've got -3 and it's being multiplied in here, I'm saying, what is -3 times positive 4x? So that's going to become -12x. Okay, let's do the second part of the Saber-Tooth rule. What is -3 times positive 2? Well, again, a negative times a positive is going to become a negative. So this is going to become -6. And this is our final answer. And the reason it's our final answer is because we have two terms that are not like terms. -12x and 6 are different types of terms. That means that we have a coefficient and an unknown variable in the first part, this part here. And then we've got this here. And actually, you know what? Last week we also did polynomials as well, and I talk about like terms. So I highly recommend, again, if you're confused by anything, just feel free to go back and take a look at that, okay? So anyways, that's our final answer for this one. So let's take this up a notch, and if anyone has any questions, feel free to let me know. Let's take this up a notch here. So let's say I had 4 times 3x squared plus 4x minus 4. Now here I have 3 terms inside the brackets, which is very important because, again, we need to become aware of how many terms there are, whether or not those terms can be added together, because knowing our bedmass rules, if they are like terms inside of the brackets, then we should do the inside of the bracket work first. But in this case, I have 3 different types of terms. I've got 3x squared, which has what we call a, what's the word I'm trying to think of? Basically, it has a coefficient and an unknown variable to the power of 2. There's a fancy word for it, but my brain is starting to go today. And then we multiply into each piece here. So again, I'm going to take this positive 4 because I know that it's a positive by way of the fact that there's no negative sign in front of it. I always assume positivity in that situation where there's no negative. And I'm going to multiply this in. So positive 4 times positive 3x squared. Well, remember that the x squared doesn't change. Only the coefficients get multiplied here. So 12x squared. And then let's multiply positive 4 by positive 4x. And that's going to be positive 16x. And then right here, we've got positive 4 times negative 4, which is going to be negative 16. And this is our final answer. The reason, again, is because none of these are like terms. Nothing can be simplified here. And so we're just going to leave it the way it is. Okay? Alrighty. I'll leave that up for a second there. Let us try something a little bit different. Actually, you know what? Let's do this. Going to do some multiplication. Okay, guys, so the types of questions that I have seen over and over again on grade 9 tests that really, really have an impact on people and are just hard to work on are these types of questions. So 4 times 2x squared minus 6x plus 1 minus 2x plus 5. So one thing I always tell our math students, do not be intimidated by long questions. It's not as hard as it looks. All of math really comes down to breaking down questions into their simplest ideas and really asking ourselves what is being asked of us and how can we accomplish that. So I know that a lot of people see questions like this and they get overwhelmed and then they just kind of shut down. And I totally get it. It's stressful when you're not taught how to properly break down questions. But I'm going to show you guys today that it's really not as difficult as it seems, so that as you keep moving forward in math class, you have those skill sets to be able to break questions down. So first and foremost, I want to say to myself, let's think of this as two separate pieces of the puzzle. Let's talk about this area first, and then we'll deal with the other area second. So that's the first thing I want to say to myself is don't freak out because it's not as crazy as it looks. So let's get my blue here. So using my blue pen, I'm going to multiply positive 4 into 2x squared, which we know is going to be 8x squared. And if you're following along, I highly recommend writing these down as I'm going along, just so that you can have a record of this, and then you can write down little notes as well if there's anything that you are not sure about. Okay guys, so now we've got that first term multiplied. Now let's go positive 4 times negative 6x. So again, our coefficients are going to multiply, and we've got negative 24x. And last but not least, positive 4 times positive 1. One tip I have for if you're writing an assignment or a test is to literally show this line, the lines that I'm showing here. The reason is because sometimes I've seen kids actually forget to multiply certain terms, and this way it actually keeps track of things for you. Okay guys, so now we've got the more difficult part. We've got negative 2x here, and we're multiplying it in. And this is the part that I've seen over and over again where kids just get confused. So, keeping that in mind, again, remember, there's a negative in front of this. This is one term. It's not minus 2x bracket 2x plus 5. It's negative 2x times the stuff inside the brackets. So you have to multiply each piece by the negative 2x. So first things first, negative 2x times positive 2x is going to be negative 4x squared. Alrighty. And now we've got negative 2x times positive 5 is going to be negative 10x. Alright. So guys, now that we've gotten this far, I'm going to get back to my black pencil here. Pen, I guess. I don't really know which one it would be considered. It's digital, so it doesn't really matter. It's erasable, so I'm going to call it a pencil. Now, what we need to do is collect like terms. So asking ourselves, what are the like terms here? Well, if it has an x squared, that means it's a like term for x squared. So I'm going to bring those together. I have positive 8x squared minus 4x squared. And if you recall from last week, when I was talking about remember and think of like terms as saying they're the same type of fruit. Here you have 8 bananas minus 4 bananas. So in the end, you'll get an answer for that. Next, we're going to see what's our other like term. Well, I've got negative 24x, and remember, these terms move with their positive and negative sign. So I have negative 24x, so I have to write it as negative 24x, and then its like term is negative 10x. So again, I'm moving that with the negative. And this is a really important step to show your teacher because you get those extra marks for demonstrating your understanding. Okay guys, so highly, highly important that we show our teachers every single step, especially if you're in Ontario. The Ontario curriculum marking system is set up in a way that showing your steps gets you the best marks. And so we've actually really suggested to most parents and to students to practice showing every little step. Even if you can jump a step in your head, don't bother. Just write it down. It'll get you the higher mark. Okay, and last but not least, I've got this situation, positive 4. So I'm going to put that at the back here. And now I'm just going to collect my like terms. So 8 minus 4, bananas as I said. So 8x squared minus 4x squared is 4x squared. Because it's the same thing as saying 8 bananas minus 4 bananas. Now I've got negative 24x minus 10x. This is the type of thing that gets people really confused. But just remember, once you're in the negatives, you're moving to the left, so this is going to be negative 34x. And last but not least, we've got positive 4, which stays the same. And that's our final answer, so I'm just going to write it down here. 4x squared minus 34x plus 4. That's our final answer. And another tip I have for you guys is to always put a box around your final answer. It helps the teacher understand that that's kind of your final answer. I keep saying answer, but that's really what it is. Okay, great. We're going to do one more of these practice problems. And then we're going to do word problems, because I think that it's really important that you guys understand the strategies for solving word problems. So I'll leave that up there for a second, and then we'll erase it away, and we'll get this show on the road. And again, if you have questions, feel free to leave them in the YouTube chat. That's really the best way to get my attention in terms of responding. You can also, if you have more complex questions that you'd like to submit to us, you're more than welcome to send them to our email address, admin@scholarlyelite.com. Okay. So let's erase this one. And again, if anyone has a question, you know, this is the beauty of the YouTube. I know that the YouTube, wow, do I not sound like an old lady? This is the beauty of YouTube, is that, you know, if you are someone who typically is embarrassed to ask questions in class, and say, for example, you know, I know a lot of parents want you guys to not share your actual names on YouTube. I highly recommend, if you're watching this every week, just create a YouTube account that doesn't have your name in it, and then feel free to leave questions in the chat. That way it doesn't show your real name, and none of your information is shared in any way, and then you can ask questions without feeling like anyone knows who you are. Okay guys, let's do a question that's a bit of a doozy. So we're going to try this. We've got, and again, these are real questions that I've seen on grade 9, like not exactly the same questions, I changed them, but these are the types of questions that I have seen on grade 9 tests. And sometimes I'm kind of flabbergasted by the level that they put on the grade 9 tests, but that's why we want to make sure that everyone understands everything. Okay, so this is a real doozy, you guys. And I say that not in the sense that it's unsolvable. It absolutely is solvable. But to someone who's just starting out with this math unit, it might look a little bit difficult. And that's why I'm going to teach you how to simplify it. So again, when I tell you that it's really, really important, and I'm actually going to leave the original question like this, and then I'm going to rewrite it here so that I can express what I'm trying to say here. So it's really important to separate these into their typical, not into their typical, into their separate areas of actually needing to do the math. So let's express that given some color. So this is one thing. This is another thing. This is another thing. And this is final. This is the final thing. Now, the reason I'm showing you this is not that I expect you guys to do this every time. If you're starting out and you're not sure, you can kind of describe which ones are separate by the fact that whether or not you need to do any operations in that section and whether it affects anything else. So that means that, for example, 5a squared b is going to stay where it is. Okay. 3a is also going to stay where it is because nothing has changed for these guys. There's no multiplication, no changing of signs. But for this one, we have a negative times a negative, and that needs to be changed to a positive as per our rules over here. Oh, not that rule. Where is it? The final rule, this one here. Let me just erase that. It's going to bother me. There we go. Cool. So if I have negative 1 times negative 7a, that's going to become positive 7a. It smushes into one sign. Those negatives go away. We don't worry about them. This is what confuses a lot of people, is that they think, oh, well, do I need to add negative, positive a. No, it becomes one sign. That's really the gist of what I've been trying to show you guys with integers, okay? Now, here, we need to determine how we can split this up because it can't stay in the brackets forever. So we're going to have positive 1, because again, when you see a positive sign just by itself in front of a bracket, technically that's like saying positive 1 times all of these things. So positive 1 times 3a squared b is going to be positive 3a squared b. Very nice. And then we've got positive 1 times negative 4a, which is negative 4a, because positive times a negative is a negative. Wonderful. So that's this section here. Okay, I should be putting equal signs in. My apologies. Now, let us collect like terms. So again, a like term just means that they have the same unknown variables in terms of the exponent that the variables are to, and also the same terms inside, so the same letters. Well, keeping that in mind, I can see that 5a squared b has a squared b in it, obviously. Oh gosh, that's quite... There we go. So we have 5a squared b. And then I also have positive 3a squared b, which is exciting because I can put those two together. And I know that they're like terms because I have a squared, b, a squared, b. And if you had seen a squared b just by itself, that also is a like term because technically that means 1a squared b. But we won't worry about that right now because there's nothing like that. Here I have positive 3 and positive 3a and positive 7a. So I'm going to write those two together. And then I also have a third like term for that one, which is negative 4a. So let's bring these as a simplified answer as possible. Now, what does that mean? Well, that means that for the like terms, that's one set of like terms, this is another set of like terms, we need to add their coefficients. Because again, a like term is just basically like saying you have this many apples and this many apples. How many apples do you have altogether? So in this case, I have 8 a squared b's altogether. That's a 2. There we go. And then here, 3 plus 7 is 10. 10 minus 4 is 6. So I have positive 6a. And this, my friends, is... Ooh, let me get rid of that. There we go. This is our final answer because these two terms are different, and so they cannot be added together. It's like saying this is 8 apples and this is 6 bananas, and we keep them separate. Okay? Again, if anyone has questions, you're more than welcome to drop them in the chat. And if you don't have questions, that's okay. Either way is fine. We're going to do one more practice example, and then we're going to switch over to doing these types of problems, but as word problems, because that's where people get super confused, and that's where you can actually get a lot of marks on those tests. And I want to stress to you guys how important this unit is. If this is a unit that you struggled with this year, I really, really recommend that you keep on practicing, keep on trying. You will get to a point where you feel confident doing it. Again, I want to express to you guys that math is a practice-based skill. People are not just good or bad at math. Yes, there are some people who are born math geniuses, and that's lucky for them. That's awesome for them. But most people are not born just knowing math. In fact, no one is born knowing math, but I'm saying some people are just born being, fabulous geniuses. I personally am not one of those people. I'm a person that has to work at doing math, but that doesn't mean that I'm bad at math. That actually means that I'm trying and I'm putting in the effort and I get to where I want to be by practice. The same way you would practice hockey or soccer or whatever it is. Cristiano Ronaldo didn't get to where he is today by not practicing or by playing soccer just once a week. He probably practices every single day. Anyways, that's my rant. I like this very Halloween theme that we've got going on this page, but we're just going to leave that. And we're going to do one more practice problem. So let's take a look at this, because it has the type of problem that I want to show you guys. So we have 4x times 2x plus 1 minus 3x minus 5x x plus x minus 1. Okay, my first step in doing these types of questions is I need to look inside of the brackets and determine, sorry, let me write that down. Look in brackets for possible work to be done. So if you guys want to write this step down, I highly recommend doing so. So step 1, look inside the brackets for possible work to be done. In this case, if I look at each bracket separately, so in this bracket I've got 2x plus 1, nothing needs to be done there, so I can rewrite this part of the equation just as it is. I'm not changing anything there. Here at negative 3x, nothing can happen here yet. Negative 5x is not being subtracted from negative 3x in this scenario. A lot of kids that I've tutored have had this kind of, they make this assumption that, oh, well, I should subtract these. No, because negative 5x is part of this squad right here. And that is a multiplication, so that's going to take precedence. That's going to be first. But before we do anything, I want to check inside that bracket and see what can be done here. Well, inside this bracket, I actually have two like terms. I have this 1x and this 1x. So I'm going to add them together and I'm going to get positive 2x. This negative 1 does not change because there's no like terms or anything to deal with it. So now, again, I'm going to go ahead and separate my sections just for my own sake. I'll use pink because we never use pink. So this is its own section. And very, very important to understand, this is its own section. Okay, so negative 3 doesn't get subtracted with negative 5x because even though they're like terms, it doesn't matter because negative 5x is being multiplied by this bracket here. So we do that. And that's its own section. So let's deal with the sections piece by piece. And let me just go back to my normal pen color. Okay, so here we've got 4x times a bracket with 2x plus 1 inside of it. So we're going to go ahead and multiply that in. So 4x times 2x is going to be 8x squared, you guys. Be very, very aware of these squared situations. So the reason it's squared is because of our exponent law called the product rule, which again, we might just do another refresher before the end of exam season, but again, keep that in mind. So we've got 4x times 2x, and that is 8x squared. Then we've got 4x to the power of 1 times 1, and that's just going to be 4x, because anything times 1 is just the same number. And then negative 3x stays the same. And here we've got to deal with this part of the equation. So again, keep in mind that this is a term, negative 5x. It's not separate from the negative. So we have to multiply it in as negative 5x. So here we go. So we've got negative 5x times positive 2x, which is going to be negative 10x squared. Then we've got negative 5x times negative 1. This is where things get crazy, and really just be careful because you want to make sure that you're creating that as a positive now. So a negative times a negative is a positive, and I get positive 5x. Yay! Okay, you guys, so we've gotten this far. Let's go ahead and collect like terms. So step 2 was separate into work sections. Okay. And now step 3 is to collect like terms. Woohoo! We did it. We did it. We did it. We did it. Yeah. Sorry, guys. I often feel like Dora the Explorer when I'm doing these freemathhelp.ca videos, live streams, I mean. And so sometimes I like to sing Dora the Explorer. Okay, so let's collect like terms. 8x squared I want to see if there's anything else with x squared. I do have that. It's negative 10x. Remember, take it as a whole thing with its sign. So there we go, moving that as a whole thing, negative 10x squared. Then we've got positive 4x. Let's see what else has an x attached to it. So I've got positive 4x. I also have negative 3x. I take that as it is. And I've got positive 5x. And if you're a person who really thrives having visuals, just actually do these circles. Who cares? Your teacher will actually be grateful that you are showing your work. Okay, so let's go ahead and put these into their situation. So we've got 8x squared minus 10x squared. That's going to be negative 2x squared. And I leave it like that. Then I've got positive 4x minus 3x, which is going to be 1. And then plus 5x is going to be 6. So then we've got positive 6x. And that, folks, is our final answer for this question. And if anyone is confused, feel free to drop a question in the chat. But if everyone is okay, we're going to move on to doing those word problems. I also want to state something very important. Ugh, my coffee today is nasty. That's not what I wanted to state, but my coffee, it does not taste good today. But more importantly, I really, really, really suggest, as a person who has been tutoring math for many years, that you take these and really work on them at a good pace. Do not rush through these questions. These questions can so easily be mixed up that even the best mathematician, if they're rushing, might mix up terms, might make a little mistake, and it's not worth losing a mark to get out of your test faster, to get out of your assignment faster. Okay? So it's totally worth it to just keep practicing and to work at a good pace. Okay, guys, so let's go up to our first word problem. Super exciting. So as you can see here, it says 3 consecutive numbers, and here I might make these words larger just so that everyone can see. Oh gosh, there we go. 3 consecutive numbers have a sum of 48. What are the 3 numbers? Okay, so again, when we look at word problems, we really just want to identify what has been given to us and what are they asking. So let's look at what has been given to us. In this case, we've been told that there are 3 consecutive numbers. So actually, I'm going to change the word consecutive to 3 numbers in order. So 3 consecutive numbers, an example of 3 consecutive numbers are 5, 6, 7, or 11, 12, 13. It just means 3 numbers that come one after the other. Cool. So we have 3 numbers in order, and they want us to use let statements. And they also have told us that, so this is one of the things that they've told us. Then they've also told us that the numbers, actually we should put this here, one after the other. This is a very common question. So if you guys are in grade 9 right now and you haven't done this unit yet, I highly recommend write this question down, write the answer down, follow along with us so that you have this as a practice question for later. So 3 numbers in order, one after the other. Cool. And then we have 3 numbers, so the numbers add up to 48. Okay, so that's what a sum is. A sum is an answer of an addition problem. So we've been given this information. Let's write our let statements. So when we get problems like this, we are going to use letters to describe the numbers. So I'm going to say let x be or you can even say represent. That's probably a better way to do it. So we're going to say let x represent the smallest number. Cool. So if I know x represents the smallest number, then I also know that that number plus 1 is the next number. because that's just standard, right? Like if three numbers are one after the other, for example, 3, 4, 5, then I know that 4 is 1 greater than 3, and 5 is 2 greater than 3. So I can express that using these types of expressions. So let x plus 1 represent the second number. And then finally, let x plus 2 represent the third number. All right, you guys. So we have written our let statement. So that is a good part right there. That's a whole point in the question. Excellent. So here we go. This is step 1. Actually, this is technically step 2. This is step 1, showing what you've been given. So step 1 is show what you've been given. Step 2 is write your let statements. Now, given all of this information, let's go ahead and start solving. So the third piece of information that they gave us is that all three numbers add up to 48. Well, if I know that I have x as the first number, x plus 1 as the second number, x plus 2 as the third number, I can actually write that like this. X, and then in the brackets, x plus 1. And then here we've got x plus 2. And they all equal 48. Great. So now I've described this, but it's not simplified yet. So just like we were doing with our other polynomial expressions, we have to simplify, get rid of the brackets. So let's go ahead and do that. Well, here I have positive 1 times x plus 1. So this x, the first one, stays the same. Then this multiplies in, I get positive x. This multiplies in, I get positive 1. Same thing here, this is positive 1. Again, when you see a positive sign by itself, it's technically like saying positive 1 times whatever's in the bracket. So here I've got positive 1 times x. Yet again, that's positive x. And positive 1 times positive 2 is positive 2. And it all still equals 48. Alrighty. Now, let's keep looking here at what we've got to do. We have to collect those like terms. So x is a like term, positive x is a like term, another positive x. So let's bring those together. So I've got x plus x plus x. Then I've got these numbers by themselves, which are also like terms. So that's going to equal positive 3, because I'm going to put together positive 1 plus positive 2 equals 48. So let's bring this situation up over here so that everyone can see. So here we're going to get 3x, because x plus x plus x is like saying 1x plus 1x plus 1x, or to simplify it for you guys, it's like saying 1 apple plus 1 apple plus 1 apple is 3 apples. Alrighty? And then 1 plus 2 is obviously 3. And then it still equals 48. This now is where we start incorporating our knowledge of algebra. What that means is that we are going to isolate for x. Okay? So let's go ahead and do that. And I like to think of the unknown variable x as a guy who has the, I've always used the example, a guy who has the plague, but now with coronavirus, I'm going to say this is a guy who has coronavirus, and we need to get him into isolation. He has to be by himself. He has to be quarantined. Everybody needs to move away from him. Just for until he's better, okay? Now, let's go ahead and do that. First, we have to move this positive 3. So if it's positive 3, the way that I can move it is move it to the other side, make it negative 3. So this is going to become 3x equals 48 minus 3, which equals 3x equals 45. And then here I have 3 times x, and the opposite operation of that is divide, so I'm going to divide 3 off of both sides. Cancel, and I get x equals 15. So that's the first part here. So we've got step 3, polynomial work. Step 4, algebra. Great. Let me just put these words in here as well. So step 2 is let statements. And step 1 is just show given info. Okay, there still is work to be done though, because even though we got the answer for x, we still need to determine the rest. So first number, hashtag means number, you guys. So first number was 15, and then the second number is x plus 1. So second number is 15 plus 1. And again, show these steps. Even though it's kind of self-explanatory, it's good to show the steps. So we get 16. Third number is 15 plus 2. Excellent. Wonderful. Okay, you guys. So this is that. And then because this is a word problem, you would answer this in a sentence. So you would say the 3 consecutive numbers are 15, 16, and 17. Alrighty? Numbers are 15, 16, and 17. And then if you're not sure of your answer, you can always plug it back in to check. But that's okay, we don't need to do that right now, because I know this is right. So this is the answer. That's my attempt at a rectangle. Take it as you will. So that's how we answer this type of question. Okay, so step 1, you have to show what you've been given. Step 2, write your let statements. Remember, those are worth marks, so it's really important that you do show that work. And then you can just go ahead and do the solving for the polynomials on step 3. Step 4 is using algebra, and then we go ahead and get our answer. Okay, so moving on to the next question here. Actually, I'll give you guys like 2 seconds to write that down if anyone's copying along. Take a sip of my disgusting coffee that I need to stay awake. And we shall move on to the next question. Okay, this is another type of polynomial question. So let me just move this over to the corner so that we can have space. So one angle of a triangle. Oh, give me a second. There we go. One angle of a triangle is 33 degrees. The second angle is twice the third angle of the triangle. What is the measure of each angle of the triangle? So whenever I get triangle questions, just for my own sense of sanity, I literally will draw a triangle, because it helps me visualize this. So I already know that this angle here is 33 degrees. That's exciting. Well, let's write down what we've been given. We know that we have angle of 33 degrees. I also know, just based on my knowledge of triangles, that all 3 angles of a triangle add up to 180 degrees. Wonderful. Oh, let me just fix that. Great, like all triangles, adds up to 180. And then I also know that the second angle equals 2 times the third angle. So, in a situation where I've been told something like that, where the second angle equals 2 times the third angle, what I'm going to do is pick which of these angles I'm going to describe as x. And we're going to use those let statements again, ladies and gentlemen. So get your pencils out and let's write them down. So I already know that one of the angles is 33 degrees. Now, keeping that in mind, I see here that I have a second angle and a third angle of which I don't know the answer or the degrees. In that case, I'm going to say to myself, well, which one is likely the smaller angle? That's how I'm going to pick which is the x. So I'm going to say let x, or we'll call it angle A. This can be angle A, and this can be angle B. So this can be, or you can even call them angle 1 and 2. It doesn't really matter. There we go. So let third angle or goodness guys, I'm writing these backwards. Sorry. Let x represent the third angle. And then because I know that the second angle is 2 times x, I'm going to say let 2x represent the second angle. Okay, so now let's create our statements. So this was step 1. Here's step 2. Now we want to create those statements. So if I know that all 3 angles add up to 180 degrees, and I know that one of the angles is 33, I'm going to say 33 plus x, which is the third angle, plus 2x, which is the second angle, equals 180, then I've created my statement that I can use to solve. But remember that we're doing our polynomial work, so we have to make sure that we're bringing together like terms. So this is going to become 3x, and I can just move these around in here. And I know that for a lot of people, like, the fact that I'm just switching these is something that confuses people. In math, we have something, it's a property in math where basically it means that the same, sorry, let me start that sentence again. Saying 3 plus 4 plus 5 is the same thing as saying 5 plus 4 plus 3. And that's why I'm able to move these around this way. Because saying 3x plus 33 is the same thing as saying 33 plus 3x. Okay, moving on. So now we're going to do our algebra here. So that's going to become 3x equals 180 minus 33. Alrighty. So we're going to get 3x equals 147. And then we're going to do our division. So we get 3x divided by 3 equals 147 divided by 3. Excuse me, guys. And x is going to equal 49. So the third angle is 49 degrees. But let's go ahead and finish the solve here. So if I know that angle A is 33 degrees and angle B is 40, or angle C, I guess, technically, because that's the third angle. So angle C is equal to 49 degrees. And I know that angle B is 2 times 49 degrees. I'm going to write that out as well. 2 times 49, which equals 98. That means that my triangle's angles are going to be 33, 49 degrees. I should put my degrees in there. And 98 degrees. Alrighty, guys. So that's that. If anybody has any questions, please feel free to let me know. And then basically for this type of question, again, you would write an answer in words. I'm not going to do that because I know you guys are capable of that, and we showed that in the last sentence, in the last problem, but definitely important to finish this word problem with a word answer. Okay? So I'll leave that up for a second. Let you guys take a look. And do we have enough time for another problem? We might do a simple one, just for the fun of it. Alrighty. Okay, so let's go ahead and do one more problem. Actually, let's see what I wrote down on this part here. Oh, this is a good one. So find 3 consecutive integers. Again, that means that they're numbers that are one after the other. Integers means that they can be positive or negative, so keep that in mind. Such that the sum of the smallest and 7 times the largest is 68. So these are 2 parts of this question, and we need to make sure that we're really, really understanding both, okay? So let's move this over. Find the sum of 3 consecutive integers such that the sum of the smallest times the large and 7 times the largest is 68. Okay, guys, this gets things a little bit more complex. What we need to do here, again, as soon as you see 3 consecutive integers, that means that you're going to have let x plus 1, let x plus 2. As soon as you see that, you should write this down. Okay, so let x represent the smallest integer, let x plus 1 represent the second integer, and I'll write consecutive just for the sake of it. Consecutive. That's a u. Integer. And let x plus 2 represent, I'm just going to write rep the third consecutive integer. Now, instead of telling us how much these integers add up to, they've given us kind of a more complex way of describing it. So they're saying, find the 3 consecutive integers such that the sum, I mean, they are telling us what they add up to, but it's a little bit more complex. So such that the sum of the smallest and 7 times the largest is 68. So let's go ahead. If we know that the smallest number is this one, that's x. So we're going to have that as our first part. And then 7 times the largest. Well, the largest is this one, x plus 2, because that's the third number in the consecutive. So then I'm going to say plus 7 times x plus 2. And all of that equals 68. So we're going to rush this a little bit just because we've got the grade 10 class coming in shortly. But basically here we're going to multiply in 7 to those. So we've got x plus 7x plus 14 equals 68. We collect like terms, so then we've got, this is technically 1x. X by itself is the same thing as saying 1x, so then I've got 8x altogether, plus 14 equals 68. And let's go ahead and algebraically solve for x. So if I've got 8x equals 68 minus 14, then I'm going to get 8x equals 54. Divide by 8 on both sides. And remember, when you're doing that, you have to make sure that you're showing that division on both sides. Whoops, there we go. And then x equals, sorry guys, 1 second, equals 6.75. And that's fine because we can actually just get the other two. So if x is that, so then I have the first number equals 6.75. The second number is 7.75. And the third number is 8.75. Okay, so that's our final answer. Again, you would want to write that as a word, as a sentence. And that's that. So thank you to the grade 9s who joined us today. I hope you guys have an awesome week. We'll see you again next week. But in the meantime, stay safe, have an awesome day, and we'll talk to you guys soon. And if you are in the grade 10 class, welcome. I hope you're having a wonderful day so far. We're just going to get set up here for you guys and we'll get started. Alrighty? Awesome. So, move that over here. Just grab my grade 10 book here. Okay. So, let us move forward, shall we? Into the grade 10 class. So today, if you got sent here by your parents, you might know that today's lesson is going to be about sine law and cosine law. I'm going to start with sine law, so hopefully we get through enough questions on sine law first, and then if we have time, we'll do cosine law as well. But before we get started with that, first I want us to kind of reiterate what we learned last week, and the week before, which is SOHCAHTOA. But also it's very important for us to understand that triangles follow very, very specific patterns. And that is going to help us in this lesson today. So up until now, we've been talking about triangles that are right angle triangles, meaning they look like, where'd it go? It's hard to scroll with this. So a right angle triangle, this is a right angle triangle, this right here. Oh, 90 degrees in it. One of the angles has 90 degrees. And it has a hypotenuse. The Pythagorean theorem applies to it. And all of those identities that we learned last week apply to this type of triangle. But today, we're actually going to be learning about how we can solve non-right angle triangles. So I'm going to get rid of that stuff there. Get rid of that. So we are going to be solving, oh gosh. Let me see if we've got a triangle in here. We do. So we're going to be solving non-right angle triangles. Okay, you guys? So let's just write that down. Great. Now, what that means is obviously there's no right angle, meaning there's not a 90-degree angle in these triangles, and that means that the laws of SOHCAHTOA that we learned last week do not apply in this scenario. So, keeping that in mind, what we need to learn are some new laws. Now, again, keep in mind that the law I'm about to teach you, the sine law, that's going to be used for non-right angle triangles. I'm also going to set this triangle up in such a way that it can be described as triangle ABC. Okay? So what that means is I'm going to have this angle A, capital A, this angle capital C, this angle capital B, and then their opposing sides. So for example, the side opposite of B is this one, little b. The side opposite of A is little a. And the side opposite of C is little c. Okay. Now, what's really, really important is that basically we are able to split this into two right angle triangles. And that's why this sine law works. We're not going to get into all of that because I want you guys to have a good understanding of how to apply the sine law first. But keep that in mind because it does make things a little bit easier. So there are two ways that we can write the sine law. I highly recommend you write this down if you haven't learned this yet. So we've got the sine law. The main way that I suggest writing it is by putting the unknown variable in the denominator. But I'll show you what I mean. So if I have this as my sine law, so sine of angle A over side length A equals sine of angle B over side length B equals sine of angle C over side length C, then that means that I'm solving for the angles, not anything else. But if I'm solving for side lengths, I could put the a in the numerator, the side length a. Okay, so just give me 1 second here. We'll put that all together. Okay, wonderful. So now let's start to apply this, because without applying it, it just makes so little sense. So we're going to start to apply this. Now, like I said, the sine law can be written in either way. Both ways are accurate. It is a ratio, basically. And it's very, very good for us to remember that whatever we're solving for needs to go in the numerator. So if you're solving for a side length, put the side lengths in the numerator. If you're solving for an angle, put the angles in the numerator. Another thing I want to state is that just remember that even though there's 3 pieces to this, you're only ever really going to be using 2 at a time. This is something that a lot of kids have asked me about when I was tutoring them, and that it seems to be neglected in the lessons usually. Not by all teachers. A lot of teachers do teach this, but sometimes it is neglected in the lessons. So let's go ahead and use a different color just to kind of show that we are doing a problem. So let's say I had this triangle. Oh, let me fix that last one. It's a lot harder to draw straight lines than it looks on here. Not that straight, but pretend that those lines are straight. So I've got this triangle, and in this triangle, they've told me that this angle is 40 degrees, and that this angle is 60 degrees, and this side length is 12 centimeters. Great. What they want us to solve for is this angle. And they've used the letter X, and I'm going to continue to use the letter X so I can demonstrate to you guys that it doesn't really matter what the letters are, as long as you know what to put with what. So again, when we're stacking these to solve, I'm going to put 40 degrees with this side length and 60 degrees with this side length, because it's always the opposite side length that you stack in that fraction. Now, you are able to write out what you've been given if you want. A lot of people do that. I find that that's confusing for most people. So what I do suggest is just to kind of take it piece by piece. So let's look at what we're looking for. Again, that's your first question you need to ask yourself anytime you're solving any type of math problem. What are you looking for in this answer? And in this case, we are looking for a side length. So we're going to put the side lengths in the numerator. So I'm going to have side length X that I don't know, and that's associated with this right here, angle. That should be a star. So that's going to be sine of 40 degrees. And then again, you follow that same structure. So because I'm looking for side lengths, I'm putting the side length 12 in the numerator, and I've got sine of 60 degrees right there, because that's the associated sine angle. Now, if you have your calculator in front of you, I highly recommend bringing it to the table now and start using it, because it's very, very good to get into the hang of doing this. But before we start plugging in numbers, I really don't recommend starting out by plugging stuff in yet, because you're just going to get a bunch of decimals, and it's easier to manipulate this equation first. Now, just like in algebra, because this whole unit, you guys, trigonometry is like 90% algebra. So if you're someone who finds algebra difficult, I highly recommend going back, practicing as much algebra as you humanly can in as many different types and forms of it as you can, so you can get the hang of it a little bit easier. Okay, so let's go ahead and solve for x. So x is in our numerator. We need to solve for it. Let's do that. What I want to do is get x by itself, so I'm going to multiply both sides by sine of 40. And what that's going to look like is like this. X over sine of 40 times sine of 40. because we wanted to cancel out and equal 1. And then on this side, we've got sine of 40 times 12 divided by sine of 60. Great. So I'm going to move all of this stuff over now, just so we can get a better look. I'll keep that like that. Okay. Great. Now, this sine of 40 divided by sine of 40 is going to equal 1, so I'm left with 1x, which is the goal here. And I'm going to plug this into my calculator. Now, first things first, we need to remember bed mass. So we're going to go 12 divided by sine of 60 in the brackets. And then whatever that answer is, I'm going to multiply by the sine of 40. Actually, give me 1 second, guys. So do them separately. So go sine of 60 first. I don't know why. Oh, let me check my calculator mode. Give me a second, guys. Now, I highly also recommend if you have your calculator in front of you, go to the mode button. Make sure you've put it into degrees. Sine of 60 should be positive. There we go. So 12 divided by sine of 60 times the sine of 40. And you should get 8.9, which we're going to round to 10. Or sorry, not 10, 9. What am I talking about? Great. So there we go, you guys. That's our answer for this one. Great. So remember, we are solving non-right angle triangles with the sine law. And keeping that in mind, as we are solving sine law, it's very good to basically always put the term that you're looking for into the numerator. And if you have side lengths in the numerator, you have to have side lengths all across the numerators. If you have angles in the numerator, you have to put angles all across the numerators. Great. So I'm going to leave that there for a second. We're going to erase. Actually, what we're going to do is this. I'll just change my pen color, and we'll try a different problem. So this was over here, the purple is one problem. This is question B. I'm going to call it question 2. It's just easier. Okay, question 2. So let's say you've been given this triangle. And in here, you've been told this is 85 degrees, and this side length is 14 centimeters. And actually, one thing I forgot, I didn't put degrees there, or sorry, centimeters on this answer. My bad. Remember to keep your units intact, okay? Then we've got 16 centimeters here, and even though this looks like a right angle triangle, it's not, because it's not 90 degrees, it's 85. And then we're looking for something called theta. So this is a term that you're going to see over and over again in math. It's a Greek letter. It looks like this, looks like a little guy, a little circular man holding his arm out, or like a guy wearing a hat. I don't know, whichever way you want to call it. So this is called theta. And it just means unknown angle. It's the same thing as saying unknown angle. Wonderful. So, since the side measuring 14 centimeters is the opposite angle to the unknown angle, that's the one we care about first. So in this case, I'm solving for an angle, so I'm going to write out my sine law like this. So sine of theta over 14 equals sine of 85 over 16. And the reason, again, is because I'm solving for an angle, so I want that in the numerator. It makes my solution faster and easier. It means I have to do less moving around. And just like before, to get rid of everything around sine of theta, I'm going to multiply both sides by 14. And the reason is because technically the unknown variable of theta is being divided by 14. So the opposite operation is multiplying by 14. So let's go ahead and write that in here. And the whole purpose is to cancel that out. Sine of 85 over 16. And then these cancel, and I'm just left with sine of theta equals 14 times this fraction. Wonderful. Alrighty guys, so let's move this over a bit just so that we have more space and everyone can see what I'm talking about. So also I want to make something clear. As you can see here, I'm not using all three pieces of the sine law. I'm only using two at a time. So for example, I'm just doing this part or just doing this part. The reason that they show it as all three is because the actual identity is true across the board in a specific triangle. But that doesn't mean that you use all three. And that's something that I've seen a lot of kids get confused by. So just make yourself aware of that you're only plugging in two at a time because that's how we solve things algebraically. Alrighty. So, actually, let's, let me just erase that real quick. There we go. So sine of theta equals 14 times sine of 85 over 16. There are a couple different ways to go about this. You can go ahead and get your numbers. So if you want, you can plug into your calculator sine 85 divided by 16 times 14, and you'll get some long decimal. But if you are going to do it that way, keep in mind you have to write the whole decimal out because you're not at the end of your question yet, so you don't want to miss out on any of these numbers that you've got in here. But I'm going to show it this way just because this is how most kids find it easiest. You can also leave it the way it is in describing it. So there's two ways to show this. Okay, I'm going to show you what I mean. You can either do what I just did, or, so this is the first way to show it, or you can do it like this. Now, I'll show you what I mean. So I want to isolate for theta, and the only way to do that is to get sine to the negative 1. So if you look on your calculator, where you have the letter or word sine, sin, right above it you have a little thing that says sine to the negative 1. The way that you access that is you press shift on your calculator, and then you press sine, and then you get that sine to the negative 1. And all you have to do is plug in the answer that you got earlier. Okay. So you should get 60.6 here. But I'll show you how this looks on this side. So technically what's happening is I'm dividing sine off of both sides and then doing all that fun stuff. But if you're confused by what I'm about to do, go watch last week's video where I explain this completely. But just for the sake of time today, we're not going to go ahead and show you each step. I'm just going to show you how you're supposed to show it in class. So theta equals sine to the negative 1 times this whole number, 0.87167036. And then you just get theta equals 60.6. Or you can just say 60, doesn't really matter. I'm just going to double check that real quick. So sine of 85 divided by 16. Yeah. Great, and then theta can just be rounded to 61 degrees. I'm going to show you how to show this another way. So here, if you've got sine of theta equals 14 times sine of 85 divided by 16. Another way to show this is by saying theta equals sine to the negative 1, and then you keep all the stuff as it was. And I actually recommend this more. I don't like writing tons of decimals on tests. This is actually the more clean way to do it. It's just that some people find it confusing, so I don't say that everybody has to do it this way. But it is a possibility to do it this way, because it's still going to get you the same answer. It's just cleaner in your numbers, and you're not writing a bunch of decimals. And then you just get the final answer, and it's going to be the same thing. So that means that our answer gets us 60. So if we look back at our normal, or at our triangle, we've got 85 and 60. 1. So this is 61. Oh. This is 61 degrees. Okay, if anyone is confused by that, we're going to do another example, so do not worry. But if they want you to solve the whole triangle, you now have 2 of the angles, and you can just get the third angle by subtracting 85 and 61 from 180, because we know that all 3 should equal 180. Okay, you guys, so let's go ahead and do another example. Oh, sorry. Alrighty, guys, so let's try this one. Let's use, no, let's use purple. So in this triangle, you know what? No, I'm just going to get a triangle from here and put in some stuff. There we go. So we've got 20 centimeters. And across from that, we've got the 70 degrees. Here we've got 60 degrees. And this is a bit of a doozy because they're asking us for this side length. But it's not as crazy as it looks because we can just go ahead and solve backwards. So if I know that a triangle has 3 angles that add up to 180, then I can solve for this angle, no problem. So I'll just go 180, actually, yeah, we'll show it this way first, equals 60 degrees plus 70 degrees plus some angle that we don't know, we'll call it theta. And then to get theta, we just go 180 minus 60 minus 70 equals theta. And then you plug that in, and you get 50. So here, this angle here is 50 degrees. Great. Now keeping that in mind, we are going to generate a sine law. So remember that our standard sine law can be written either with the angles on the top or the side lengths on the bottom, with the angles on top, side lengths on bottom, or the reverse. In this case, I'm solving for a side length, which means I need to put the side lengths in the numerator. So I'm going to go ahead and say x over 50, or sine of 50, remember that, equals, and then I'll just pick this other one because that's what I've been given. So I have 20 over sine of 70. Okay, so remember, if you're putting the side lengths on the top, you have to keep it that way. If you're putting the angles on the bottom, it has to be that way again. So just be aware of that, okay? Okay, so let's go ahead and solve, again, just using our standard method where we move this over. So we'll go x equals sine of 50 times 20 over sine of 70. Do not plug in your numbers until the very end. And then do the bracket first. So you go 20 divided by sine of 70 and times that by sine of 50. And you should get 16.3. That's your answer. So this right here is 16.3. Okay, great. So keeping all of this in mind, we're going to move on to the cosine law for the next half an hour, just because that one takes a little bit longer. If people are not fully understanding this, please, please, I implore you, leave the questions in the chat so that I can help now while we're still working on this stuff, okay? Otherwise, we're just going to keep on trucking and move on over to the next situation. So just give me 1 second. Alrighty. So now we're going to learn about cosine law. And again, for cosine law, we are discussing non-right angle triangles. That's very, very important to remember. And I'm going to get my little triangle pen here. Non-right angle triangles, meaning they don't have an angle of 90 degrees in them. Okay, great. Now, the cosine law is another kind of standard way to calculate either the measure of an angle in a triangle when you know all three side lengths, or you can finagle the equation a little bit to get a different way. So I'll show you what I mean. And I'll show you what kind of is the standard way of approaching this. So if I have an equation, it's going to be, sorry, the cosine law is this, so I'll have you guys write this down. Cosine law. Okay guys, so write this down. It's very important that you write this down like this. A squared equals b squared plus c squared minus 2 bc times the cos of A. And I'll show you what I mean. So if I have angle capital A and its associated side length little a, and same thing goes for these ones, capital, little. Great. So in this scenario, basically what I always want to make sure people understand is that the letters don't matter necessarily as long as you're associating the right letters with the right things. So this letter A that's in the front here, this here is a side length squared. Side length A, but it has to correspond to this angle A. Okay? Be very, very aware that if you are putting the answer in the front here, you have to make sure that the angle that you put back at the end is the associated side. And then the other two side lengths are just kind of whatever. It doesn't really matter which order you put them in. So you have side length B times side length C squared. Sorry, plus. My bad. Let's get that positive sign in there. And I always write this out for students because I've just found over the years that this really helps people kind of visualize it. Minus 2 times the side length B times side length C times cos of A. Okay, this part of this unit, the cosine law, is the one area that I found in grade 10 seems to be a huge piece in terms of people being confused. So I'm going to show you guys my methods on how we simplify this. So the first thing I mentioned earlier that's really important to remember is that if you are setting this up, it doesn't really matter what letters you use. You can use X, Y, Z. You can use whatever. It doesn't matter. Most importantly, whatever number, whatever side length you put outside of the rest of the equation, whatever you're making everything equal to, okay? So this has to be associated with the angle at the end because it's the angle across from it. So I don't care what letters you use. You don't even need to use letters. You can use symbols if you want. I don't care. Don't use symbols. I'm just kind of joking. But it doesn't really matter as long as that first letter and that last letter are in reference to two things that are across from each other. One always has to be the side length in the front, and then the cos of A has to be the one across from it. So let's go ahead and try some examples so that this can make a little bit of sense. Some teachers teach this in a way that, I don't know how to explain it, but basically they just rearrange this over and over again. It doesn't really need rearranging. You pick the side that you care about, and then that's what you use. I'll show you what I mean. But there's also a way to rearrange this like this. So the cosine of angle A is equal to b squared plus c squared minus a squared over 2bc. And, you know, if we sat and did this algebraically, it makes sense. It's not difficult to do. Okay? Okay, guys. So, let's go ahead and start using this information to the best of our knowledge. I'm going to try making this whole thing smaller. Oh, look at me. Look at me being fancy. It worked. It's exciting. Okay, so let's keep that over here. I hope everybody had a chance to write that down. If you didn't, please feel free to write it down. Let's go ahead and solve this. So typically, your teachers will give you just a bunch of questions and they make you decide whether you should use sine law or cosine law. One of the tricks for knowing which to use is kind of just asking yourself, what have I been given and how does that factor into what I need to know? So in this case, let's do an example like this one. If I've got triangle, I'm going to draw that here, and this triangle has a side length with 8 centimeters. It has a side length with 10 centimeters. It has a side length that I don't know. And it has an angle of 50 degrees across from the angle that I don't know. This is like the simplest version of a cosine problem that you might get because they're literally asking you for the side length that's right across from the angle. So you have everything you need on the right side of the equation to plug it in. Now let's see what that means. If my cosine law is this, a squared equals b squared plus c squared minus 2bc times the cos of a, then I need to determine what I have and what I don't have. In this case, like I said, remember that the cosine angle that you use, the angle or the cosine of the angle that you use has to correspond to the side length. So because I'm solving for the side length across from this angle, that's perfect. So I'm just going to call this angle A, and I'm going to call this side length A. Simple as that. I choose. It doesn't matter what letters your teachers have given you. As long as you plug the numbers in right, it really doesn't matter. All right, guys. So let's go ahead. I don't know what A is. That's what I'm solving for. So I'm going to leave A squared as it is. Now I'm just going to arbitrarily pick B and C, meaning it doesn't really matter which is which, as long as I continue to call them the same thing. So this can be side length B, and this can be side length C. So 8 centimeters squared plus 10 squared minus 2 times 8 times 10. And then this is where the important part comes in, cosine of 50, because that's the angle across from the side length that I don't know. So cosine of 50 degrees. Great. I highly recommend you do this in 2 pieces. You do this part first, and then this whole part second. Okay, let's do the first part first. So we have 8 squared plus 10 squared. So we have 164. And then I'm going to leave this part as it is, 2 times 8 times 10 times cos of 50, because I'm going to show you guys how we're going to do this. So everybody get their calculators out, because this is the part that everybody gets confused by, and I want to make sure that you guys understand, okay? And if you do these steps in this order, you won't get confused. So leave 164 as it is. Think of this as its own situation and work either right to left or left to right. It doesn't really matter in this scenario. Basically, all I need you guys to do is remember that this is -2, so you have to multiply it as a negative into this scenario. So you can just plug these in all together. So you can just put on your calculator so bracket -2 times bracket 8 times bracket 10 times cos of 50. And if you just put brackets next to each other on your calculator, it'll do the math for you. So here we get -102. And remember, I multiplied -2 in, so now it's not negative, it's just -102.85. I rounded that, but that's whatever. And then I'm going to get this math, and I'm going to keep writing a squared because that's also important to remember. So now I'm going to go 164 minus my answer. So that's going to be 61.15. Well, not what I was trying to do. Cool. 0.15. And then this is squared, so I want a by itself, which means I need to square root both sides. Because the square root of a squared is just the number by itself. And this is a very important step. Don't forget to do your square roots at the end. So a equals the square root of 61.5, which is 7.8, which we are going to round to 8. Yay! We did it! Okay, I'll leave that up for a second for anyone who wants to write that down, and then we'll try another example. Okay. Alrighty guys. Let's keep on hustling. We can do this. So in this scenario, we were solving for side length. We're going to do another side length example down the line. But first, we are going to do an example where we're solving for the unknown angle. So let's just start a new problem here. Okay, guys. Oops. Oh, I just told that my voice sounds like a robot. Let me see if I can fix that. Give me one second. Give me one second, guys. I'm going to try and see if we can fix that. So this is the interesting thing about these headphones, because it often works, but then on occasion... Yes, and I also want to shout out to my cousin who told me that this sounds like a robot. Okay. Interesting. So we're just going to do some trial and error here, see if it does anything. Hopefully it gives us a better sound quality. I think it's fixed. Hopefully it's fixed. Okay, great. So, wonderful. Let's keep on rolling, you guys. Let us try. Oh my gosh, there we go. We reconnected. All right, guys. Yeah, sorry, because I cannot hear myself in terms of like what I sound like to you guys. So I appreciate the squad telling me when I am off base. Okay, guys. So let's keep on adding up some stuff. So let's say you've been given a scenario where you have 3 side lengths and no angles that have been told to you. You can still solve using the cosine law, because remember, this is one version of the cosine law. But there's also a rearranged version of this where you're solving for the cosine. Now, one way that we can make ourselves do so is the following. So we move over, we switch negative 2bc to this side. And I'm just showing you guys the steps of how we're going to isolate. You don't actually have to show this every time. So you move negative 2bc over to this side, and it becomes a squared minus 2bc equals b squared plus c squared. And then you move a squared over, so this stays as negative 2bc times cos of a equals b squared plus c squared minus a squared. Oh, sorry, this is not negative, this is plus. My bad, because you moved it over, so that's fine. Let me just fix that. Because we moved it over, it became positive. Great, and then we divide off. Let's fix that. 2bc divided by 2bc, and then we get cos of alpha, or a, whatever, equals b squared plus c squared minus a squared over 2bc. So we're going to use this formula. Wow, my straight line drawing today is just a mess. Great. And I've been given the go-ahead to proceed. Thank you. Much appreciated. So let's plug in our numbers that we know here. And you don't really need to care about what the letters are other than the letter that you're solving for and the one across from it. So in this case, we care about this. This is going to be angle A, and this is going to be called little a in terms of its side length. These other two don't super matter in this case, so I'm going to call this one B and this one C. Great, let's plug all that stuff in. So we've got cos of A equals 6 centimeters plus 8 centimeters squared. That's what I was trying to say, squared, minus 7 squared over 2 times 6 times 8. So let's go ahead and plug that into our calculators, ladies and gentlemen. And remember, it all still equals cos of A. So we've got 36. And I would show this step just for the sake of it, just for the sake of getting those extra marks. And then minus 7 squared. So you can basically go ahead and show that. Oh, sorry, 1 second. So in this case, we're just going to get minus 49. And 2 times 6 times 8 equals 96. So here we've got 36 plus 64 minus 49 divided by 96 equals 0.53. And that equals cos of A. And then to get the actual angle A, we need to do cos to the negative 1. So both sides are going to technically have that situation, but we're just going to have this as A equals cos to the negative 1 times 0.53. Great. And so plug that into your calculator, cos to the negative 1 times the answer, and your answer for angle A should be 57.9, which we're going to round to 58. Yay! So, one thing that I want to make very clear, why did we get negative 49 here instead of positive 49? The reason is because negative 7 was not in brackets. So this is like saying minus 7 squared, and because of bedmass, the exponent goes first, and then the subtraction. If it was minus 7 in brackets squared, then it would have been positive 49. But in this case, it's not. Okay? It's like saying 7 times 7 and then putting that behind the minus sign. If anyone's confused by that, let me know. I can show you another example. But if everyone's okay with that, we're just going to keep on rolling and see what we get. Okay, I'll let you guys write that down for a second. Wonderful. So let's try another example. Again, I can't express to you guys enough that these really come down to just practice, practice, practice. Watching me do it will help you understand on kind of a cognitive level, but you need to be able to do this yourself. Okay, so let's try this. Now, sometimes you will get situations where you need to apply the cosine law and the sine law together to solve for what's going on. If we have time, we'll do one like that, but I want us to do another cosine law just so that everyone can get the hang of it, and we can keep on trying as best as we can. Okay, so what we're going to do is actually try one that's a little bit more complex. Give me a second. Okay, so let's move this over and put in our numbers here. So we've got this angle is 43 degrees, the number across from it here, and actually, just give me a second, guys. I'm trying to find one that would be a great example for you. Next week, what we're going to do is we're going to try some word problems with these, because these get to be very complex in the word problems situation. But before we move on to word problems, we have to understand the actual skill that we're working on first before we do anything else. So that will be more important. Just going to find you guys another problemo here. So, you know what, we could just do this one and then say that we need to exclusively use cosine law. Let's double check if we can. So L M N 140 meters. Okay, so in general, let's say that our teacher told us that we're only allowed to use cosine law for this, or to ask if we can use only cosine law for this, because sometimes you will get problems where the teacher says, you know, look at this problem, can you use cosine law to solve it? And in this case, I've got a side length where I know the opposing letter, and I need to solve for everything else. So I'm going to show you guys how you can apply the cosine law in a way that is useful to you in situations like this, if a teacher says to you that you can only use cosine law. So remember that the angle at the end of cosine law has to relate to a known side length that's across from it. So in this case, I've got 43 degrees across from 120, which means that if I'm plugging these in here, remember that the side lengths and the letters and stuff like that, the letters don't really matter. You can call these whatever, as long as this term and this term relate to the side length across from the angle. I sound like a broken record, but I really need you guys to kind of have this in the back of your heads at all times. Everything else is arbitrary. So let's go ahead and plug these in. So I've got 120 because it's the one across from the only angle that I know. So that's going to be squared. I'm going to call b squared the unknown side length here, which is technically little m, but it doesn't matter. I'm going to call this capital B for the sake of it. Great, so I'm going to go ahead and plug that in as b squared because I don't know what it is. Here I've got c squared, which is 140 squared, minus 2 times b, where did it go? Times c. Times c, which is cos of 43. Now, I want you guys to know that this is solvable, but not necessarily at the grade 10 level. Like it is because you guys are learning polynomials and stuff. So you could technically solve this, but in general, you're going to want to use sine law in this scenario because it's so much easier to just set up a sine law where you've got like 120 over sine of 43 equals, what is the word I'm looking for here? 140 over, what is it? Yeah, sine of some unknown variable. And then so on and so forth, right? In this case, you can solve working backwards and doing that. So we're just going to leave that there. So this is what I wanted to show you guys, is that sometimes your teachers will give you questions where you're not sure which one it is. You kind of have to do trial and error. So don't let yourself get down if you start one way and you don't get the answer. Okay? So let's move on to doing another cosine law question. Okay. So let's try this question. If I've got a triangle and the side lengths are 17, 23, and 24, I have no other information about this triangle. No angles, no nothing. This is a prime candidate for cosine law. So let's reiterate what cosine law is. A squared equals b squared plus c squared minus 2 times b times c times cos of a. And remember that you can do these as separate little pieces in this equation. In this case, though, if they're asking us to solve the triangle, when you see the word solve the triangle, what they're really asking you to do is give every single unknown. So in this case, we don't know angle A, we don't know angle B, we don't know angle C, and that's really important for us to understand. So when we don't know the angles, the cosine law can be rearranged to be like this. Cos of A equals b squared plus c squared minus a squared over 2bc. So this is a really good thing to memorize. Okay, guys? Or just practice your rearranging, and so if you don't memorize it, you can rearrange the cosine law to get this at any time. So let's go ahead and plug some stuff in. So if I'm going to call, let's say we want to know angle A, which is this one, because they've given us the letters. That means that this angle A has to correspond to that side length that's right across from it. Great. So again, I don't know angle A, so I'm going to leave that the way it is. I'm going to plug everything else in kind of arbitrarily. Not arbitrarily because they've given us letters here, so we can plug them in as they correspond to those letters. So in this case, we've got 24 squared plus 17 squared minus 23 squared, because that's the corresponding side length, all over 2 times 24 times 17. So just be really careful about which letters and numbers you're putting as which, because you can easily mix those up and it's not worth losing marks for. So guys, let's plug these into our calculator. We've got 576 plus 289 minus, so 23 squared, we've got 529. Remember, this sign doesn't become positive because this is the same thing as saying positive 23 squared being subtracted. Okay, that's something that a lot of people lose marks on, and it's something I want you guys to be really aware of because it's not worth losing marks. Okay. And then this equals, obviously, 576 plus 289 minus 529. So that's going to be 336 over 816, which equals approximately 0.4118. So I'm going to show that down here. Great. So cos of A equals this. So I get this answer. And I plug that in there. So 0.411. I'll just put 76 and then we can actually go ahead and do the rest later. So then A is equal to cos to the negative 1, 0.41176, and then A equals 65.68 degrees. Yay! We did it, you guys. So now you can go ahead and use sine law if you want to solve the rest of the triangle, but realistically I'm just going to plug this in as 66 degrees, part of the devil's number there, and you can go ahead and solve the rest using sine law or whatever you want to do. So a couple things, guys, I really want to make sure we understand before we move away from this is that, again, the ways that I've seen people lose the most marks are that they're not relating this with this. That's very, very important. The letters tend to confuse people. It doesn't really matter what the letters are. You have 3 side lengths. As long as this side length, this angle that you've got here corresponds to this side length that you've got here, that's all that matters. They have to correspond to one another. Other than that, these letters don't really matter. You could call this, you know, it's the same thing as saying like x squared equals y squared plus z squared minus 2yz times cos of x. It's the same thing as long as x and x relate to each other. Okay? Hopefully that makes sense for you guys. And I'll just leave that there for a second for everyone to look at. So, like I said, next week we're going to be expanding upon this. We're going to look at some word problems, and that's really where we're going to get a good understanding of what's going on. Because this is a pretty important unit. You will use cosine law and sine law in the future. What was I doing here? Because we only really have, I think, 5 weeks left of freemathhelp.ca. 1, 2, 3, 4. Actually 4 weeks left, because depending on if you guys have school that last week, it just really depends. But likelihood is that we're going to have our last freemathhelp.ca in a month from now on June 18th. I could be wrong. I'm going to double check with our local school board here in Simcoe County just to see when they're officially ending school. But yeah, so that's that. Let's see what we've got here. Oops. Let's do one quick sine law just to get you guys refreshed on that before we go. And then that's that. So we can adjourn after this, and then you guys can have a great week, and we can come back next week to do some more complex stuff. So kind of the way that I set these up is that 1 week I will do the lesson, like the main lesson, and then the week after I will show you guys the more complex versions of the problems that you'll see pertaining to that or relating to that lesson. And if you missed, you know, the week's lesson from before, all of our YouTube videos on the channel are just videos of the live stream, so you can feel free to go back and watch at your, you know, during your free time. Okay, so let's do one more. Let's say we've got okay, let's try this one. 62 and 60 centimeters. And then here we've got 70, and I don't know that angle, but I want to know this angle. Okay, so this is actually, again, not too difficult because first things first, I can solve for this angle. If I have 2 angles, I'm golden. I can just go 180 minus 70 minus 62. Get that answer. And then plug that in here. So now I'm solving for this side length, right? So again, with sine law, you want to put the thing that you're solving for in the numerators of the fractions. So in this case, the sine law I'm going to use is going to be A over sine of A equals B over sine of C equals C over sine of C. Because again, this is a ratio. It doesn't really matter. But in this case, I'm going to call this one angle A and this little a, and I'm going to call this one angle B, and I'm going to call this little b. So let's plug that stuff in. So again, I'm putting the numerators as the side lengths. So we go x, the unknown, over sine of, sine of 48, my bad, equals 60 over sine of 62. And I'm just going to rearrange by multiplying both sides by sine of 48. And that gives me x equals sine of 48 times 60 over sine of 62. And we will get our final answer as, so remember, do your brackets first. So 60 divided by sine of 62. Be aware of whether or not your calculators is in degrees mode. Be aware, very aware of that. And then times sine of 48. So you're going to get 50.49, which we can also call 50.5 degrees. And that's our answer for this one, you guys. So thank you very much for joining us. We are all set to wrap up now. If anyone has any questions, feel free to drop them in the chat. But otherwise, we are going to meet again next week. Next week, like I said, we're going to continue with the sine and cosine laws, but we're going to be doing much more complex problems, which are word problems, and learning the ways to apply strategies to those word problems. Alrighty, guys, so hope to see you again next week. Have an awesome day. Hope you're safe. Hope you're well. And as always, if you ever need to talk to someone, please check out kidshelpphone.ca. They're an awesome, awesome service that is a wonderful way for you to get yourself someone to talk to. Okay, so have a wonderful week, and I'll see you guys again next week. Have a good one. Bye.